Our goal for the experiment was to establish a relationship between the densities of different concentrations of a given sugar stock solution. The materials needed are as listed: a 10 milliliter graduated pipette, a pipette bulb, an 100 milliliter graduated cylinder, a balance, a 25 milliliter volumetric flask, 2 150 milliliter beakers, and your laboratory notebook. We first began by transferring around 50 milliliters of both the stock solution and the dyed water to separate beakers to be used for pipetting later, as directly pipetting from the container could lead to contamination risks. We began the experiment by obtaining a 25 milliliter volumetric flask and then weighed it for its mass. We then used our graduated pipette to measure out 5 milliliters of the stock solution, filling it to where the bottom of the meniscus met the 5 milliliter mark.
The meniscus shown here is a curve that occurs at the top of a solution when dealing with glassware.
It occurs because of the tendency of the solution's molecules to adhere to one another, as well as the tendency of the solution's molecules to adhere to the glassware's polar molecules.
When calculating the volume of solution with glassware, be sure to use the bottom of where the meniscus forms, not where it adheres to the glass.
Back to our experiment. We transferred the 5 milliliters of stock solution to the volumetric flask and then weighed its mass on the scale, ensuring we close all windows of the scale. We used this recorded data to find the mass of just the solution, as well as to find its density as shown here. Next came the dilution of our stock solution. In order to determine how much water to dilute our substance by, we use the dilution equation. C1V1 equals C2V2. This equation represents the relationship between the volume and concentration of a solution before and after dilution. We use this equation to determine the volumes of which we need to dilute the stock solution by in order to achieve concentrations of 15, 10, and 5%. Using our previous data points, we plugged in the initial concentration of 20% and volume of 5 milliliters into C1 and V1, and obtained the following final volumes of which we needed to use by plugging in concentrations of 15, 10, and 5% into C2 respectively. We began our dilution of 15% concentration by transferring the water from the beaker to the volumetric flask using our 10 milliliter graduated pipette, ensuring that the water did not rise up into the pipette bulb and that the bottom of the meniscus sat at the needed measurement. We then placed our diluted substance on the scale, weighed it for its mass, and then recorded it into our notebook. We repeated this step 2 more times, diluting the solution to concentrations of 10 and 5%, and recorded both their masses.
The table pictured here shows the mass and volume we recorded for each concentration of the diluted stock solution. We took each solution's mass and divided it by its volume, giving us the density pictured on the far right.
We plugged each solution's concentration and density into a table, which gave us the graph pictured here. The data points we plotted onto this graph, and a linear line of the best fit was made to show the relationship between each plotted point. The equation of this line is pictured to the right, as well as this r-squared value of 0.9918, which showcases how well the plotted line fits the regression and how reliable it is. Displayed here is the notebook which we recorded all of our data for the lab, the concentrations of our solutions, their mass, the volumes, the densities, and the graphs of our data.
We aren't completely done with the lab, however, we still need to clean up our lab space. We cleaned up the space, pouring out all the liquids down the sink drain as they were safe to be disposed of, and rinsing out all glassware under the faucet and placing them back in the storage. That concludes our lab. We hope the video was informative and helped you understand the lab. Thanks for watching.